Hi again. Welcome back to INST 314, Statistics for Information Science, and we're jumping into the third of our 4-video series on basic data management in R. We've talked about how you bring data into R and how you look at some of the objects. We've talked about how you can explore them through summaries and subsetting them to look at bits and pieces of larger variables and data frames. But now the third video is going to take us into recoding, when we can create new variables and shape new objects based on this previous information that we've learned about. So let's go ahead and get started. So as we can see from the lecture goals, we're most of the way through the basic data management R. We're now onto the recoding, and next we'll have coming up outliers and missing values. So let's jump into recoding. Briefly, I want to touch on the factors and levels issue because this can become a bit of something you're going to have to know about if we're working on the recoding with factors. I said before that factors are integer values that can have a sort of text component label that sits on top of them that we often see them. They can be ordered or unordered, so you can think of these like nominals and ordinal variables, but they have to be coded properly. So one of the things we're going to do as an example here is to show you how some of these coding levels can be worked. We're using a data set called moocs final.csv, and I'm calling it moocs as it is here. I believe a little bit of a typo up at the top of the screen where I have moocs there as a capital M, but it's actually been stored when I was working on it with a lowercase m. I think that was just PowerPoint doing an autocorrect on me there. moocs is referring to a massively open online course of students that had taken online courses, and this is a subset of the data. So this particular one, if we're doing the structure command, shows that we have 18 variables and 5,300 observations. And so we're going to be looking more specifically at the variable LOE_DI, which is a degree level. If we look at it here in the structure function, it refers to that being a factor variable with 5 levels. We can see this a little bit more specifically if we run a class function on it. So we're doing class. Inside the class parentheses, we have the moocs $LOE_DI, and it says it's a factor. We can use the nLevels function to ask how many levels do we have, and it reports 5. Using the levels command, taking off the n, it reports and says there are 5 levels: bachelor's, doctorate, less than secondary, and for those not quite sure what that means less than high school, master's degree, and secondary, which would be high school. And then at the bottom it says the level codes are 1, 2, 3, 4, 5. So those are the integers underneath, and then these are the text labels saying on top. This would be an unordered component. Let's go to the next one. There's another function. I love this function. We're going to talk about it a little bit more when we get to descriptive statistics. But there's a package called summary tools, and inside summary tools there's a function called frec, which is short for frequencies. And part of this, I have clipped out part of the output because we're not dealing with the descriptive stuffs at the moment. But it tells us in this one right there if it's ordered or unordered. And so what I've done in this case, it says it's unordered, and what in the example code below is we are reordering it. So I'm using a factor function, and I've taken the moocs LOE_DI, and we're saying we're going to take that variable, we're going to make it a factor. It already is a factor, but we're making a new variable. We're storing this into LOE_DI2. So we're taking the LOE_DI, and some of the options of factors, I'm saying use the levels option, and then I have the C, and I'm indicating the levels that I want them to appear in. And you have to make sure when you do this that you spell them exactly as they appear in R. Capital letters, any punctuation like apostrophes, things like that, they have to appear in there. Otherwise, they're either going to be just skipped or you're going to get an error message. So in this case, I'm putting them in the order that I think that they should be, and then I'm using the comma order equals true, and that is going to reorder those for me there. And then if I run the summary tools frec, it tells me the type is factor with it being ordered. And I can check my recoding. Always, always, always check your recoding. Make sure you've done it properly. And in this case, I'm using a table function, and I put in one variable, comma, the second variable. And what that does is it makes what we call a bivariate table. We're going to revisit this later in the next module section on descriptive statistics. But in this case, I can use it just to kind of give a visual inspection to say, all right, the original variable that we had, LOE_DI, And the new variable we created, LOE_DI_2, where did my recoding go? And so if we cross-reference these, less than secondary had 146 individuals, and it is also in less than secondary. And if I look at people who had set secondary, there was 1,732, and I check my table values. The only people that identified as secondary also appeared as secondary in the other ones, and so on as we go across with bachelor's, doctorate, and less than secondary. When you're checking these, you just want to make sure that you're only going to get count responses in the columns and rows that it corresponds to the instructions you gave it. All of the other information in this table here should say 0 if it worked out properly. So with recoding, that was one particular way that you're doing some recoding. There's another way that we're going to use this where we're changing the code values themselves in one or more of the particular variables. There are several different types of recoding out there. The three I'm going to be introducing you to are cut, ifelse, and recode. Note, recode requires the car library, CAR, in order to run that one. Recode also appears in other packages, so I'm going to jump back a slide for a moment here. Note when I had the summary tools, I had summary tools : FREQ. That was an indicator when you write a package name with 2 colons that says, find this function specifically in that package. So depending on what packages and libraries you've activated in R, you may need something like that on Recode if you've got Recode in 2 different packages and you want to make sure you use the right one. So we're going to use the YOB variable, which is year of birth. And so what I'm doing is I've run a summary function on mooks $YOB in order to find the quartile values to find out at what ages we have. And we're going to split age 4. Instead of saying year by year, we're going to make it into 4 age groups. So what you don't see on this screen are the actual years, but where I made the cut points, but you can see them down below in the levels function. So in this case, we are creating a new variable called age4.lev, kind of short for age4levels, and I'm making this value, which is going to store just the different levels that I'm typing out. That way I don't have to type all of these years over and over again. And I'm using the function levels, and I'm putting in the number ranges for the ages, people who are 19 to 36, to 1982 is in the first group, then 1983 to 1985, and so on. These are based off of the quartiles from before. Now that I have the levels, I'm going to put them into the recode here, and I'm going to start with cut. I'm using cut, and I'm nesting cut inside factor. That way I can kind of double dip on my coding here and save a little bit of time. So we're looking inside of this at the moment. I'm going to use cut, and cut is specifically used for variables that are numeric. You cannot use cut with things that are factors and characters, things that already have text on them. But what it does is you can think of taking that number and putting them all in a big row, and then just chopping it, cutting it at different points, and putting those in between your cuts, they become a group. So I'm doing a cut on year of birth, and then I'm indicating a breaks option of where to cut the breaks. And you start with, in this case, negative INF for negative infinity and INF at the other end for positive infinity. Say, those are my far ends. If you know what the high and low values are, you could go just beyond that to make sure you be inclusive. But I just want to say everything to the far left and everything far right on my number line. And then I'm going to cut it at 1982, 1988, and 1985. I have another option there where I have labels, and I say labels are equal to that variable I just made a moment ago, the age4.lev. Otherwise, if I didn't have that in here, I would have to write out all of the level names that I want to call it. And then I'm using an option here. This is part of the factor on there. Note where the parentheses are opening and closing. So after labels, there's a closed parenthesis. That closes the cut function. Then the comma ordered is part of the factor function that cut was nested into. You could do this in multiple steps if you want to kind of keep things a little bit separate, but I kind of put it together here, and we made a new variable called mooks age4. If I run my summary tools on the frequency, here's the full output, and what appears, it says here's the frequencies for age 4. It's coming from the mooks data frame. It is an ordered factor, and there then it says there were 1,414 individuals who were born between the years 1936 to 1982, 641 that were between 1983 to 1985, and so on as we go. And it tells us the frequencies and the valid percentages for them. Another way we can do this is with the if-else function. It works similarly to most if-else type statements that you might do in Excel or some others in this case. And the way it starts out, the basic logic of this is you say, if this, and you give some criteria, then what do you do if it's true? And what do you do if it's false? So in this case, I start with an if-else. If your year of birth is less than or equal to 1982, make it a number 1. And if not, then I nest it inside of another if-else. I say, okay, if it's not less than or equal to 1982, then move on. So if you're greater than 1982 and less than or equal to 1985, then make it a 2. If not, go on to the next one. If you're greater than 1985 and less than or equal to 1988, then make it a 3. If not, go out to everything else. If you're older than 1988's year of birth, then you're a 4. If you're none of those, then I put at the very end an NA. So if it goes through all of these years of birth and they don't match up to anything that's there, then you're going to become a missing value. At that point, you were probably a missing value already if this was the case. But that's just my safety measure. And then I do my comma. So I'm outside of my if-else's and I'm inside my factor function. This is all nested into. And I say, make the labels equal to age4.lev, which we'd already stored, and make this ordered. And then if I go ahead and check this again with the frequencies, I'm doing the frequencies on the age4 from the if-else, and I get the exact same frequency distribution and percentages and things like that. So cut and if-else gave me the same response. I'm guessing you can already figure out then that we're going to do a recode this time, and the recode's going to give us the exact same grouping. So again, I said this from the car library. Recode is also in dplyr, so make sure I show here on the slide. You're going to do car : recode if you're getting some mixed messages on which recode it might be pulling from. So now I'm making age4.r as my new variable attached to the MOOC's dataset. This is recode function is being nested inside factor like the other ones were. So I'm doing recode, and inside here the code structure changes a little bit. I'm calling the variable yob, comma, and then I start inside quotes for my recode. And inside my quotes, it may seem a little counterintuitive. You may be thinking that you're working on a string. You're not. Everything inside the recode function where you're doing the recoding part goes inside quotes. And each instruction set is separated by a semicolon. You'll note on some of these recodes, I'm putting them onto multiple lines. That is simply for visual learning aids and clean code. This all could be on one line and would work just fine on one line. So what I have here is I say 1936 : 1982. So it's saying this year to this year and everything in between equals 1. Semicolon to move on to the next set of instructions. 83 to 85 and anything in between is a 2. Semicolon to move on to the next one. 86 to 88 becomes a 3. And so 87 to 213, which is the highest value in that data, becomes a 4. And then I close that off, comma, add it to the labels, tell it to be ordered. It's inside the factor, and when I move on to do the summary frequencies, it is where it needs to be and matches everybody else. Now, sometimes I just want to kind of show you here that your data does not always play nicely, and we need to use recodes in order to fix our data. Previously, we were looking at recodes because we had a particular coding strategy in mind. We were given years of birth year by year, and we wanted to group the years. That was just a strategy that we wanted to use for whatever sorts of analysis we might need to do it. In this case, we're going to have a variable that is not looking the way it should. Now, let's go ahead and take a look. In the particular example here, we're going to use some data from Starbucks on their drink menu. I'm loading in this CSV, and I'm storing it as a data frame object called SB. And I run SB, and I see that we have 242 different drink observations across 18 different characteristic variables of them. Things like what category they're in, how many calories they have, how many sugars they have, etc. So in this case, we're going to be looking at the caffeine variable, which is measured in milligrams. And what you're looking at is a table. And so you have to kind of break this apart visually here for a minute. Think that every odd row, so the top rows being the first, then the third row, the fifth row, etc., that is the number of the milligrams. And then the even rows here, the second one starting with 1 and then 7 and 3, etc., those are the counts for them. So, for example, I'm looking up there at it says a blank up at the first top row, then a 0. So there's 35 drinks that report having 0 caffeine, 3 drinks that report having 10 caffeine, etc. But when we're looking to see what might be wrong with this, it might just be easier to look at all of the levels, because these numbers are being stored as text, not as just a number digit. So when we look at this, all of the text appears into the double quotes. We can see things a little bit easier. And what is it might be popping out? Well, we can go ahead and see a few things here. First of all, the very first entry. You know what? Let me pause. This is actually a good time to mention. I said those square brackets on the farthest left, and I would come back to them when it would be appropriate. Those square brackets, as I said before, are telling you the position number for each of the printed rows that come out. So in the square brackets, we have numbers like 1, 8, 15, 22, 29, and 36. That is referring to the first row. I have 7 values. So if you count them up going across, there are 7 values that printed out on the first row, and the first one was number 1. The second row has values that are in position 8 to 14. And so the first number, that 125, is position number 8. The third row that printed out are in positions 15 to 21. So the first value there is 170. If we look on that third row, the one I have in the red box, it says 20. That's in the 4th position on that row. So you can think of 170 as in position 15, 175 is position 16, 180 is position 17, that 20 is position 18. So if we ever needed to reference specific spots, we could use these printout numbers on the side to help us get an understanding of how many values there are on the printout, where they are located, things like that. But going back to this example here then, some of the things that are wrong with this. The very first entry is just in double quotes, it's blank. There's nothing there. That looks like it might be a data entry error or something like that, because there should be either the 0 or a missing, or as it says at the bottom, the varies. The other thing wrong with this is that we see at the very bottom the 2 varies. One of them is capitalized, one of them is lowercase. And R is treating those as different things. And so that's, again, some sort of data entry error. If we were using this and wanting to work with it, we would want to combine those into a common group. The third problem, and the one that's also giving us a lot of headache, is that our values are out of numeric order. When you think of things in a number line, you start, let's say this is caffeine, and the smallest number you're going to have is 0, and you count upwards from there. So 20 milligrams of caffeine is twice as much as 10 milligrams of caffeine. But the way these are printed out, because they are text stored as characters, which is partially because of the blank first entry and the 2 different varies, R saw those and said, well, these either they're all going to be numeric or they're all going to be text. And so when it puts these numbers stored as text, it stores them in sort of an alphanumeric numbering order, so that if you look at the very top row, we've got 10, 100, 105, 110, 120, and then you keep going. And then where I have the first box around the 20, we see numbers that start with 20, 225, 235. So it's put all of the numbers that begin with 1, then all those that begin with 2, then all those begin with 3, not actually in the representative number order, and we need to fix that. So there are several methods and strategies that we can go ahead and fix this. I'm going to be showing you one way we can do it, and it's sort of a step-by-step process. Now remember before I said don't recode into the same variable, make it something new. So I'm taking the original variable caffeine ... milligram ... and I'm just calling it a new variable called caf. And so I've taken caf, and on the farthest right of that line, you're going to see an NA. So I'm sticking the value of NA, or missing, into something else. What am I putting it into? Let's look at the left side of that arrow. So if caf, and then I do a subset on caf, if caf equals capital V varies, or if caf equals lowercase v varies, or if calf equals the empty spot, make that missing. So all of those three problematic values we saw before, they're all now missing values. And then below I said, all right, go ahead and look at the factor of calf and just call it over, make sure everything's still coded as a factor, and give me the levels. So I can see the levels, and it's just a visual inspection to make sure that they're all there and the stuff I coded out as missing are gone. So then what I did is I did an as character nested into an as numeric. So it said, okay, take all of those number values that were there before, turn those numbers from factors into characters. So we're stripping away those underlying indexing position numbers, and we're just left with the string components stored as text. And then we just do an as numeric, so it takes those numbers that are being stored as text and converts those into a number equal to their character position. If we did not have the as character in the first, if we just went straight to as numeric, we would be stripping away those numbers that are stored as text and only using their index position underneath, which is going to give us a total chaos. And then what I went ahead and did is I double checked my work with a table of the original caffeine and a table of the recoded caffeine. I was not going to do a big bivariate table because there's so many values, it would be a huge output. So I'm just going to do a visual inspection of each table and see how it worked out. So what we have here is the before and after, and I said, all right, there were 35 drinks that had 0 caffeine. So if I look at my new one for calf, there I have 0 caffeine has 35 observations. If I jump over to say there was one drink that had 300 caffeine, and I go into my new calf variable and I say, okay, I find 300. Yes, there was one. So what I now have are all of the values from caffeine that have been coded back into a number form. And those numbers, once you put them into number format, they will go into a nice numerical number order. And now this variable is ready for further use for other purposes of what we have. And so this concludes the section on recoding. We're going to be recoding quite a bit in this course. So I hope that you'll get a chance to use the different values and we'll get plenty of practice.